Well, hello everyone. Welcome back to TRS with another boat anchor episode. Now, a viewer down in South Carolina sent these two pieces here to be, looked at, gone through, and repair as necessary. And over on the right, we have a National. This is the NC190. Now, this radio is a receiver. Mostly, shortwave hand bands, and it is just in immaculate condition. When you look at this thing, it is just spotless. It was really taken good care of. It must have been kept somewhere that no moisture gets to it or anything. It just looks great. One thing in shipping, the audio gain knob did come off, but that was just a loose set screw. But other than that, this radio receiver just looks great. One little chip of paint here on the front, which is no big deal. You can hardly notice it unless you're looking for it. And one little tiny blemish here on the top. Other than that, the cosmetic of this radio is just superb. I'm really surprised to see one in this condition. Over on the left, we have a Johnson Viking Navigator. Now, this is a CW transmitter, and you can see it still has the original aluminum knob on it. The rest of the knobs look great, and I mean, the face of this thing just looks great also. Radio being 55 plus years old, you expect it to have some dings and scratches on it, but this thing is just in good looking shape. We do see some worn paint around the front inside of the cabinet. Little spot here over the meter that's got a little scratch on it, and other than that, the face is perfect. The cabinet has the original paint. There is some scratches on the top where stuff has been sitting on it here and there, but it's expected for something this old. But what we're going to do today is concentrate on the Viking Navigator, and then we'll pick up the National in another video. Now, I wanted to get this thing torn down and see what it looks like on the inside and what we got to do to it to get it back up and running. Now, if we look at the meter, we can see the meter has been replaced. It almost looks like the Viking Ranger meter, but it's not orange inside. It does not have the Viking logo in it. It does have E.F. Johnson Company written on it, so no, that's not the original meter. Now, when Johnson designed these things, they must have had a lot of screws on hand, because we got screws all the way around the case on the front, all but across here, but there's screws all the way across the bottom, and there's several screws in the back going into the cabinet. So I'll get all those removed, and we'll go ahead and get this chassis out and have a look at it. I just want to spin around, let you take a look at the back of it. You see our key jack, ground, there's our crystal socket for your antenna relay, and somebody has changed out the RF jack and put a chassis mount SO239 in it. So and we got a couple of little stickers that has been put on, probably to know when somebody has tampered on it. We got 4 little screws here to get out the back. Now, this radio should push right out of the cabinet. And there it goes. It seems a little bit tight in the cabinet. It shouldn't really be this tight. But I'll go ahead and spin it around and finish getting it out. Well, I got the chassis out of the case, and man, it looks clean. I mean, very clean. But I see why the chassis was a little tight sliding out of the case. I'll reposition the camera so you can see this. If you look right here at this transformer, you can see the angle this is sitting at. You know, it's sitting here like this. If you see right here, this bracket is bent. And I'll turn it around on the side, and you can see exactly just what has happened here. You can see this part of the chassis is bowed down. Now you got to remember, the heaviest thing in this transmitter is this transformer. And I'm not thinking, you know, this thing was very well packed. It was double boxed. It had a lot of bubble wrap around it. I don't thinking that this was actually shipping damage. I think that somewhere in the past somebody has dropped this rig kind of hard on the bottom, and the weight of this transformer just pushed this chassis right on down in the middle. Now that's nothing to worry about. You know, now if this thing had a circuit board in it, it would be destroyed. But being a quality built piece of equipment like this Johnson does, you know, it's no problem. We can fix this. In fact, we can fix it, and you won't even be able to tell that it's been bent. So that's something, probably the first thing I'll have to do, you know, get all the tubes out, put the chassis up in a jig and press this back down, and then remove this transformer and straighten out the bottom feet. We probably won't have to take the whole transformer off. I believe I can just take the case off and straighten them back out with no problems. You can see just how close this tube and transformer is. In fact, it's actually touching. Lucky that it didn't break the tube or break the base off. But, you know, that's repairable. So a little hand sweep with the camera here so you can just see just how nice looking the inside of the rig is. See a couple of screws missing. There's one here on top of the VFO case, and there's another one here on the side. And one of the studs is missing from the bottom. And the screws missing from this part of the stud. So someone didn't want to take everything completely apart just to get this out, but we're going to have to do it so we can get inside of this thing. Better look at how that transformer was bent. Really, really nice looking unit. So we look here under the bottom, we can see we got the original filter capacitors in. So this would be the first thing that we'll need to change out. You never want to fire them up with these old crusty capacitors in there, because it can cause a problem. Strange looking here, there's a yellow wire with some of the insulation missing off of it, but other than that, it really, really looks good. Now I'm seeing something here that just caught my eye. Here on the front, you see we got this knob, and that is so you can plug crystals into it. But if you look right there, you see a shaft sticking out. And we look around here and we see that shaft going all the way through here to a potentiometer. So inside that cover, there's been a potentiometer mounted. So we'll have to get in there and find out what that modification is. But other than that, I do not see nothing else that has been added or done to this thing other than the SO239 in the back. But we'll get a look at it and see. Okay, as we can see, our transformer is standing straight up like it's supposed to be now. It's a very simple process. I just had to remove the bolts that mounted the transformer to the chassis, and then take the 4 bolts that hold the covers together, straighten them out, and then put it in the press, and with some wood blocks was able to straighten the whole thing. Now the bend line was about right here where it was really bent the worst at, but yeah, it's completely flat now, no problems. You can't tell that any repair has been done, so it looks real good. And we just hope that when it ships back that it doesn't take a tumble and bend it again. It's one good thing about these aluminum chassis, they are pretty simple to straighten out when you have a cosmetic issue. Now if you're wondering, we don't have to go inside this VFO compartment. There's no capacitors in there to be replaced, and the good thing about it is they did not have the regulator tube inside the Navigator, so it means there's no 18K Chernobyl resistor, as Terry would call it, inside this VFO. So if the VFO is working, it's a good, we'll check that out and see. So perhaps we don't have to tear this thing down to go inside and work on it. But what we have to do is go ahead and replace these 2 30 microfarad caps so we can power this thing up and test it out. And there's one other cap in here, right here, this big green cap. I think it's a .002. I can't remember, I have to look at the schematic, but we'll have to replace that one, maybe a .2 microfarad. So we'll get these 2 caps replaced, and then replace this green cap, and we'll give it a good look over, and we should be okay to power this thing up and see what it does. Okay, I went ahead and got the capacitors replaced, cleaned all the switches, controls. Now this is your standard filter cap, and the positive goes right to the bottom of the rectifier tube and into ground. This capacitor here is in your bias circuit, so positive goes to ground, and your other end will come up here to this circuit. That 0.5 replaced under there, a little big green monster out, and it's time to bring it up and see what I do. I went ahead and looked over everything, and it looks pretty decent, no problems. Okay, so I just shot some footage. I was bringing this thing up slowly and monitoring the voltage with the digital voltmeter, and when I got up to about 70-80 volts, my current limit supply quit on me. And it's did it before, and I think what it is, this very active transformer, it's an auto transformer, it's only about a 2 amp resistor, so that thing has popped the winding. So I either going to have to order a new auto transformer, variable transformer, or just get another whole supply. I built this thing years ago, and usually it's down under the bench, and last week I moved it up here because I was working on so many different boat anchors. So yeah, she is kaput. Okay, I had to go back to the old-fashioned way. See, I got two meters, one to measure the AC line and the other one to measure the high voltage inside the Navigator. I had to switch over and go grab the old power stat. Now this will go up to about 140 volts. That's why I need to monitor the AC input so I don't overvolt the rig with this thing, because this is a heavy duty supply. Alright, we'll put all the power on. About 25 volts. Up to about 35. You can see our high voltage is coming up. It's up to about 50 volts. Air conditioning just kicked in. It's 90 some degrees out today. See our high voltage is up over 190 volts at 56 volts input. Should reach right close to about 395 to 400 volts. 77 volts. We at 80 volts at 275. Looking good. Dial lamps are on. Volts, about 340 volts DC. And 120 volts, and we're right at 400 volts DC, so that part is looking good. No problems at all. So when I got this, I'm going to go ahead and switch it to tune. I see Greek on it, so that part's looking good. Alright, so let me reposition everything and we'll see if we got any activity. Okay, now that we know that the rig is not going to go up in smoke, I'll go ahead and we'll put the meter on grid. We'll switch over to tune. Take out the exciter. VFO will check the zero on the receiver. No problem. Go to transmit. Close the key. Dip the plate. And we're showing about 25 watts on the RF watt meter. So that's looking pretty good. Okay, I got the National 190 fired up. Now this rig, he has been using it. It still has the original filter caps in it, so he wants all everything replaced and tuned and lined that, which that'll be for another video. So now that we know that our Navigator will power up and not smoke out, put it on grid, switch over to tune, exciter, stand by, we'll switch over to plate, transmit, hit the code key, and dip the plate. And that's about 25 watts out. So that's looking good. I only have to put no coupling into it. We could do about 25 watts or so. Alright, so we're all on the 80 meter band. Let's go now and listen to the transmit and see if we notice any chirp or clicks or anything. We'll go back to transmit. And the Navigator is transmitting good. No problems. The oscillator sounds good and healthy, and seems to be working pretty good. So as you see, it didn't take a whole lot to get the Navigator up and running. I still have a few more things to do to this. I need to replace some screws. I need to go through the VFO alignment, make sure it's on frequency like it's supposed to be. A few missing screws inside I'll need to go ahead and put in and get those installed. Maybe a couple of solder joints. Again, need to test all the tubes, make sure that the tubes are all in good shape. I want to replace this wire that's missing the insulation off of it. Back here on the back of the band switch. We'll check some resistors and make sure all of those, especially underneath this cover, are in tolerance. Everything I checked down here was good to go, no problems at all. Put a little lube on these controls and the band selector control, and that should pretty much have it. So I'm looking at this modification that's been done to it, and we got one wire that goes back here to the back on a terminal strip, and there's another wire going somewhere up here at the top of the case. So I had to get this out to find out just what this modification is. I believe it is some type of resistor to vary the bias on the driver to probably, turn the power down to run QRP with. That is my thoughts on that. It's probably okay to have it what it is. They should have cut the shaft off even with the end of the socket here, so you can still use crystals in it. But with that shaft sticking out as far as it does, you can't get a crystal in there. So there wasn't a lot of these sold. That's why Johnson didn't make so many of them. The problem was you could get the Ranger, which was a CW AM rig, and the Navigator only being a CW rig. The price between the Navigator and the Ranger was so close that everybody would just buy the Ranger so they would have AM. So yeah, these weren't a very big hit. They are a bit rare, and this one is in pretty nice shape. I don't think I've ever seen one with the original meter in it. Just things like that original meter did not hold up, and about every one you see, someone has replaced the meter, and they've done a pretty good job on this one. So with that, that's about it on this one. Rest of the stuff I got to do, I'll do off camera, and when I go through the National 190, we'll pair these two up and see what we can do. Anyway, hope you enjoyed it, and leave your comments down below, and we'll see you in the next video. Bye now.